Every time you flip a switch, send a text, or turn a key, you are pulling from a massive, hidden river of power. Keeping modern civilization running requires a staggering volume of fuel. For decades, we have relied heavily on non-renewable energy. This category primarily consists of three resources: coal, petroleum, and natural gas. The defining trait of these non-renewable sources is that they are finite. They exist in strictly limited quantities buried deep beneath the Earth's surface. Take a look at this diagram detailing an underground oil reserve. It took millions of years of intense heat and pressure to form these fossil fuels, but we are draining them in a matter of decades. Simple division tells us the end result. If you divide a finite underground supply by a constantly growing rate of extraction, you get a hard expiration date for the energy foundation of our current economy. Running out of fuel is a significant logistical problem, but the act of burning it creates a much more immediate threat. Combusting coal and petroleum produces a heavy volume of toxic byproducts. We are actively pumping millions of tons of pollution into the atmosphere. This graph shows exactly what happens next. The pollution traps that heat, which forces global temperatures to rise faster than any documented period in human history. Right here is where these two extremes cross paths. Supply hits the floor, while global temperatures hit their peak. We are driving toward a dual crisis. We face the mechanical reality of global blackouts, paired closely with the severe ecological damage of a warming planet. Avoiding that intersection requires a total replacement of our energy infrastructure, and we have to build it before the clock runs out on fossil fuels. The alternative to digging for finite fuel is renewable energy. The core principle here is simple. Renewable energy is drawn from natural sources that naturally replenish themselves. They are inexhaustible. Because these sources operate without combustion, they do not emit toxic gases. They are entirely pollution-free and environmentally friendly. We generally categorize renewables into 5 main sources, beginning with the most visible: solar energy. Solar technology relies on capturing radiation directly from the sun using photovoltaic cells, turning a steady supply of daylight straight into electricity. Then we have wind energy. As atmospheric pressure naturally shifts and changes, it creates a constant kinetic force that we can capture with turbines. Between solar and wind, we have the technology to harvest electricity entirely from the daily, unstoppable rhythms of the sky above us. But the sky isn't our only option. We can also harness terrestrial and aquatic systems, starting with hydroenergy. Hydroenergy relies on the gravity-driven flow of rivers and ocean tides. Water is heavy and constant, making it a highly reliable way to spin generators around the clock. Next is biomass energy. Biomass uses organic material, like plant and crop waste, that we can process to generate heat or fuel, creating a closed-loop system where the fuel grows right back. And finally, we have geothermal energy. This schematic demonstrates how a geothermal well functions. It pulls that heat up to spin surface turbines, then cycles the cooled water back underground. It draws entirely from the Earth's internal, everlasting heat. Think about the contrast. The fossil fuel era required us to destroy the resource to get the power. This system of 5 natural forces lets us generate electricity through constant natural replenishment. When a nation transitions from finite fossil fuels to domestic natural sources, it increases its energy security. Energy security is defined as having reliable, uninterrupted access to power sources at a stable, predictable price. By drawing power from local, infinite forces, a power grid becomes less vulnerable to the price volatility and supply chain interruptions often associated with imported oil and gas reserves. This creates a foundation for sustainable development. Sustainable development is a method of economic growth that meets our current needs without depleting the resources or environment required by future generations. Transitioning to a zero-pollution energy grid stops the accumulation of environmental debt, helping to halt global warming while guaranteeing that the power stays on for those who come after us. The Earth has always possessed enough ambient power to keep our civilization running. Surviving the energy deadline just means making the shift and finally plugging into it.